Okay, now let's talk about example 3, how you could solve an equation graphically. So if you have an equation like this one says the absolute value of 2x minus 5 divided by 3 is equal to 3, and if we want to solve this graphically, what we're going to end up doing is graphing each side. So you start by setting the left side equal to y, and if you graph that, you get this V shape, right? And we talked about that in the past, why that is, because we're taking, anytime we're going to plug in a value for x, we're going to take the absolute value, so it's going to end up being positive, positive, positive. And then we graph y equals 3. Y equals 3, y equals any number is always going to be a horizontal line. And then we're looking for the points of intersection. So the points of intersection are negative 2, 3, 7, 3. And if you were to plug in x equals negative 2 and x equals 7, you plugging those both in, that would be counting as a check, and it should work out. And that will give you the y equals 3, which is the reason why we're seeing those as ordered pair, right? So since we're trying to solve this equation for the x values, that means our solutions are going to be x equals negative 2 and x equals 7, and we would put those in solution set notation, okay? So go ahead and give that a try for, well, actually, let's just talk about the inequalities too, because in terms of, you know, the way that this is different with an inequality versus an equation, the equation we want to know the points of intersection. Here we want to know when is the absolute value greater than 3. So since we have our line y equals 3, the absolute value is greater than 3 over here and over here, right? So the portion of the graph that's above y equals 3, which means that x is less than negative 2 and x is greater than 7. So this is our interval, and that's going to be an OR because you can't be in both places at the same time. So that's why we use the union. When we want to solve when is this absolute value graph less than or equal to 3, we're thinking about all of this area down here. And one other teacher that I'm friends with was mentioning how you can remember this is we say this one could be greater, and you see that word or, greater, versus less than, you get that? Where were we going there? Because here you have an and interval. When you're less than 3 is just this area below y equals 3. And so we have our interval is from negative 2 to 7. And because of the equal to, we're including those endpoints. So the solution set is not two numbers, not the 2 points of intersection, but that whole entire interval below the graph. Do you see the difference between those kind of 3 different scenarios? You have the equal to, greater than, or less than. All right, go ahead and give it a try on example 4, and then we'll discuss.